To avoid. Should issue job engineering.
So, Vinod sir, shall we start the program?
Yeah, I'm ready.
Okay, sir. Just a minute, we'll start the program. A warm good morning to each one of you. So let us start this FDP, ATAL ACT sponsored ATAL FDP on the topic robotics, the machine power for industrial automation. I welcome each one of you for this wonderful session. Starting from today, we'll be having a 5-day session. Each day is filled with a lot of information to be shared with the learned professor. Today, we are going to inaugurate this session with a keynote address as well as a special address by Dr. B. Vinod. And 83 participants have joined this session and from various parts of India, from UP, Maharashtra, Tamil Nadu, Andhra, Punjab, West Bengal, Kerala, Odisha, Haryana, and even from other states of India. So I welcome each one of you. I thank each one of you for registering this FTP. I assure you this session is going to be very much useful for you because the professors what we have contacted are having a good number of experience in the field of robotics, and we are also having different topics to be shared with you. The FTP session is already shared in the WhatsApp group. Let me give a small introduction. Today we'll be having inaugural session with keynote address by Dr. B. Vinod, Professor at PSG College of Technology, Coimbatore, followed by requirements of robots in industry by Mr. Muttappa Lal Gundi, Senior Engineer from Mitsubishi Electric India, and software introduction by same resource person. Tomorrow we'll be having a session on robotics drives and motors by Dr. M. Sundaram from PSG College of Technology, and session 2, role of pneumatics and robotics by Ms. Vishnupriya from PSG College of Technology, followed by computer vision for robots, Dr. P. Ratika from PSG College of Technology. And on day 3, we'll be having artificial intelligence for robotics by Dr. Subhashini from PSG, and we have one session on configuration and demonstration of industrial pick and place robotic arm using RT toolbox by Professor Mohan Raj from Ishwar College of Engineering. We are having a live demo on that session, followed by design and selection of gripper by Dr. S. Prabhakaran from PhD College of Technology. We have on day 4, we are having multiple robotic path planning using various techniques handled by Dr. P. Supriya from Amrita Vishwavidyapeetham University, Coimbatore. 2 sessions will be handled by Madam and followed by robot programming and operations by Dr. M. Suresh, Associate Professor, PhD College of Technology. And on day 5, we have a topic on stress management handled by Dr. Krishnamurthy, corporate trainer, soft skills and outbound freelancer, followed by the research challenges, interesting topic, research challenges in industrial robotics, Dr. B. Vinod from PhD College of Technology. And the last session will be feedback, validity, and online test. As we know that the requirement for getting a certificate is you have to maintain 80% attendance and 60% pass percentage in the test, which is going to be conducted on day 5, session number 3. It will be a multiple choice question. We will be giving you the details in the later day. And our session will be normally starting by 9:30 in the morning and it ends up by 11:30, session 1, followed by a break for 15 minutes. And session 2 will be starting from 11:45 a.m. and it will end by 1:45 p.m. We will be breaking for lunch. And after lunch, we will be joining the session by 2:30 p.m. and it goes up to 4:30 p.m. Of course, the sessions are planned for 2 hours. Maybe the resource person may be handling sessions for 1 hour or 1.5 hours based on their presentation. We will have some interactive session followed their presentation. And I request all the participants to actively participate in the question and answer session also to get your queries clarified. And we are always there to support you in all aspects. Any query you are having regarding the session or your joining the session or your attendance or your other aspects, we are always ready to give the answers for your queries raised by you people. So we are there to support you. So let us hope and enjoy this session, and let us wait for the learning aspects what we are going to take away from the FDP, which is for 5 days. So with this note, let me introduce our today's guest of resource person, Dr. B. Vinod. He is going to handle the first session today. As a postgraduate degree in applied electronics from PhD College of Technology, Coimbatore, and completed his PhD on CSC Machine Tools from Bharia University, Coimbatore. He has 8 years of industry experience in the field of industrial automation and has 21 years of teaching experience in robotics, CNC machines, industrial automation, power electronics, and drives. He is currently heading the Department of Robotics and Automation Engineering at PhD College of Technology, Coimbatore. He has successfully carried out 11 funded research projects for various research establishments like DST, DHI, NIOT, HAPP, AR and DB, and RCA for the tune of 17.42 crore. He was also instrumental in establishing 15 centers of excellence at PhD College of Technology. He has published 49 papers in various international journals and conferences. He is a member of Managing Committee, Southern India Engineering Manufacturers Association, SEMA, Chairman of Robotics and Automation Society, IEEE Chapter, Madras Chapter, member of Robotics and Automation Panel for Bureau of Indian Standard, and member Managing Committee, Co-India, Coimbatore. With this rich profile, Dr. B. Vinod is with us. He will be handling the first session. I welcome you, sir. I thank you, sir, for accepting our invitation. Let me hand over the session to you, Professor. You can now take over the session. Thank you. Now, unmute. Sir, your microphone is in mute.
Oh, sorry.
Thank you, sir.
Okay, thank you. So thank you, Dr. Rajan Babu, for the nice words, and thank you for the introduction. Very good morning to each one of you. Very happy to see that there are 80 registrations. Hopefully others will join soon. Yes, as I understand from Dr. Rajan is that all of the registered participants are teachers. They are all faculty members of various institutions in India. And online education is not new to us. We have been practicing this for the last 1.5 or almost 2 years. So we know the strength as well as weakness of this online learning, whether it is a classroom or whether it is a faculty development program. So the success of this program depends upon whom? If you really want to have some takeaway or some learning from this FDP, it is you who is going to decide the success. So unless your complete participation is not there, you may not be able to take what it is intended. If your intention is only to get a certificate, yeah, again, there are conditions laid down by Dr. Rajan, like you have to have at least 80% of attendance. But again, that is only the physical. Nobody is going to monitor whether you are interactive in the sessions, but leave alone the certificates. Certificates we can get from anywhere. But the whole purpose of any faculty development program is first to enrich the teachers first. And the ultimate benefit from learning something new is to the student community. So whatever we have learned, we need to practice. So we take these learning to the classroom. We can really motivate youngsters. The students can sometimes do better things than teachers. So from the learning of this FTP, I strongly believe there will be some value addition to each and every student of you who will be attending your classes. If you have any difference of opinion, please let me know. The time you invest here should be worth, and please be interactive in the sessions. Ask any questions, any number of questions. It is not, as you know, we are all teachers. All the people who are in this webinar, we all teach. So we know the fundamental ethics of teaching. So we don't like, when we take online classes, we don't like our students to come late. We don't like our students to walk in and walk out as you wish. We don't like our students to misbehave, because there are also ways to do a lot of things in the class, in the session. So let us take a pledge that we will not do all those things. If we are attending, let us attend it to the full. I know you are all committed, you have got other commitments, but at the same time, if you decide that I'm going to attend this program fully, it is possible. But if you feel like, okay, this session looks a little boring, let me complete my physical personal work or official work, yeah, then chances are there. And as you have seen, the sessions are planned like it is almost 1.5 to 2 hours per session. So the attention span of most of the people these days are less, that we have observed in our physical classes. There is a recent study that says that 3 to 7 minutes. If more than that, if you keep on telling something, chances that people will get bored. So let us ensure that we discuss something new after every 5th or 10th minute. There are various ways of making this happen. The best is to have interactions. So I need complete participation of all of you who are attending in this FTP. If you go through the session plans, yes, some of my colleagues from PSG, they are handling some sessions. They're all really experienced and knowledgeable in their own area. And there are also experts from other institutions giving their expertise or expert lectures. This is a platform for all of you to connect, talk, and become friends. So hopefully I'm going to get around 80 plus new friends today. So thank you, Dr. Rajan, for this wonderful opportunity. And I'm sure this FTP offered through Sri Ishwar College of Engineering will be of immense help, and ultimately to the student community. So students, either we guide them for their learning, or seniors for research, maybe PG students or PhD scholars. in mentoring them for their research work. So hopefully this program will give a new direction to the interesting area of robotics. So being the first session, my job or what I thought is on the first day, we will have the basic understanding of robots, because while discussing with Dr. Rajan, I found out that some of the profiles you are new to robotics, and there is a mixture. Some are from electrical background, some are with mechanical, some with computer science. So uh, though robotics is a perfect combo of all those things, all those disciplines of engineering, uh, becoming a master of robotics requires a lot of practical experience in all these fields. So this is cross learning is going to happen. Like if I'm mechanical background, I am with mechanical background, this stage I will be utilizing for learning more of my knowledge on the actuators, drives and sensors as well as controllers, so that I can able to integrate the mechanical systems to the electronic control systems. So that is the objective. So with that, I have some slides. So we will run through the slides. So whenever you don't have to continuously look at the slides, but listen to the talk. Please ask questions whenever, wherever you feel like asking questions. Don't wait till the end, because by the end, sometimes you may get distracted or you may find something else interesting. So please ask your questions as and when you have some doubts. Okay, so now let me present my slide. And I hope it is visible. I thought of starting the introductory part, the robotics. It is really a fascinating. It is not that it's going to be the future. It's already there. Robotics is not a new word. It has been there since 1920s. So that old is the word robotics. Okay, and my experience in or the department's experience in conducting such programs. So currently I'm heading the Robotics and Automation Engineering Department of PSG College of Technology. Before going into the content, I would also like to, sorry, that just me. So before going deep into the content, I would like to give a small introduction about the department with one slide, because there are several faculty members from this department going to interact with you in the next 2-3 days. So a small introduction. I'm not sure whether how many of you know that PSG College of Technology is a government-aided autonomous institute in the state of Tamil Nadu, started in 1951. And this is under the PSG and Sons Charitable Trust, which started in 1926. The BE program in robotics and automation is the youngest program of this institution, of this PSG College of Technology, and this program was started in the year 2011. So it is 10 years since this program, this BE program has been running, and we are launching our PG program, I think by the next year. So we have two undergraduate programs. One is called as BE Robotics and Automation Engineering. Second is the Mechatronics Engineering. This Mechatronics Engineering is an international program where we have some partner universities from countries like Germany, Australia right now, and some universities from US also will join. So a portion of this curriculum they study in our department, The rest, probably the final year in the case of German system, and 2 years in the case of Australian system. So it is 2+2 for Australian program and 3+1 for German program. So these students, they migrate to the foreign university in the final year or the pre-final year, and they get the degree from those universities. So I have not added the number of graduates in the international program. The other numbers which you see are only with respect to the BE Robotics and Automation. So we have 486 graduates since 2011, of which 309 placements happened through the campus or through internships. 151 have been to top universities in US, Germany, Australia, Switzerland, UK, all for higher studies. Most of them landed up in MS in robotics or MS in AI and robotics or MS in industrial automation. And we do have an opportunity for foreign university internship. So 34 students have so far been to foreign universities for internships. The department has produced 26 entrepreneurs. So there are a lot of startups. The students have brought us around 116 awards. So right now, around 315 students, 21 MOUs with various industries, and 11 centers with industry partners. That is a brief about the department. The remaining things, if you are interested, I will share, or you are welcome to the department so that I can take you around and show us the facilities. We do have the best facilities in terms of robotics and automation in the country. The department is ANB accredited. We have several funded projects. The total funded projects so far is around 35.5 crore. You can see some of the pictures here. This one. The first one is demonstration of a surgical robot trainer developed by the department and with L&T Technologies in partnership with Korea Advanced Institute of Science and Technology. We do encourage school children to come and play with robots in the department. So the second one, the school children enjoying their summer intern inside the campus. And there is one picture of one of our students from the first batch involved in the Valkyrie mission to Mars in the NASA labs. And here is one product, a special purpose welding machine, which we have developed with another funding. Some of our students were involved in the Mahindra Rise car, autonomous car competition. And some of the products developed, some of the awards received by the students. So PSG has developed our own industrial robot. Some students from this program, they participated in the World Skills Olympiad in Brazil that happened in 2019 or 18. Then, yeah, some of the MOUs. So this is a short snap of the activities of the department. And about robotics, yeah. So we discussed, it's not that new. There were stories, science fiction stories, novels, movies. So right from 1917 till 2021 and still robots have been fascinating humans. I'm sure you would have seen some of the movies from this collection. How many of these movies you have seen? This Modern Times was a movie of Charlie Chaplin. It's a very popular one. Hope you have seen this. If you have not seen, please download and watch, or at least you can watch in YouTube or Netflix or something. So Modern Times is a movie that was made in 1936. So a company looking at their orders, they feel they are fully loaded, but employees are taking a lot of time during their break, during their lunch break. So in order to, and that reduces their productivity. So the owner thought that, so somebody told the owner that there is a robot available to feed the people, so that if this robot is introduced to the shop floor, it will increase the productivity, because people will not go away for having their lunch. Instead, they can work and they can also have lunch. So this machine was introduced to the shop floor, and our hero was asked to test this machine. So Charlie Chaplin does the first testing. First phase it went on well. Second phase, the robot misbehaves, its speed increases, goes haphazard, and the poor reaction of Mr. Chaplin makes us laugh. So that is about that movie, even in 1930s. Then series of movies. I just took some clips, some of them popular ones. This, I think, most of the people we have seen. Indiran by Rajinikanth, directed by Shankar. And the latest one is by Tom Hanks, Finch. So all these movies, and this iRobot, another highly successful movie, which was a movie made out of the novel written by Isaac Asimov. These all, see, humans have this greatest gift of imagining, like creativity, fantasizing. So the robot is actually the result of a fantasy or an imagination by human. Then who did that first? So Carl Capek. He is the person. He lived from 9th January 1890 till 25th December 1938. So he used to write novels. So he died at the age of 48. So during 1920s, he wrote a play. So this is the picture of that play. Maybe some played sometime later when cameras were there. So they have captured a scene from this, which is available in internet right now. So human-like objects were made, and they were asked to follow the commands of humans. And that was the first concept, but it was only for a drama. So, and that was the first, and it is a Czech word. Robot means a forced labor. So Mr. Karel Capek was the first one to use this word in his play. That is how it all started. Then I'm not sure you have heard about this gentleman, Mr. Isaac Asimov. He used, from robot, he used the word robotics. So whatever we used to describe about this field, about the robots, the study, so that is called as robotics. So he is a Russian born, but lived in America as a scientist and a science fiction writer. He lived from 1920 to 1992, and he has written several novels, science fiction novels. And he is considered as the father of robotics. So please Google Isaac Asimov and his novels, and you can read some of his novels. Some have become movies, but some are still very interesting novels. So please read, and you can imagine the kind of creativity this person had even during the 90s or 1940s. That is the time when he started writing about robotics. So from, I'm sure some of you would have seen a lot of James Bond movies. What is the specialty of James Bond movies? Anyone? You can unmute, you can talk something. Please don't be a passive listener. And if you have any comments so far also, you just try to respond or reflect. What is the unique or something special about James Bond movies? Okay, so I'm the only one in this class. All others have left. Okay, I understand that. I want at least someone of you to speak.
Good morning, sir. I think many new things that will be introduced in that movie, sir, like a new weapon, new car.
Yes. So things which are not available, they project like these things are as though it is available. So actually, most of the things what we have seen in James Bond movies became reality later. So initially they make something to show us, and later people carry on with the research, will contribute and try to replicate what they saw in these movies. So they were ahead of time always. So Isaac Asimov was such a person who used to think ahead of what others used to think, and those thoughts he converted into writings, and that became his novels. So most of the human inventions, these are all actually the result of some wild, crazy thoughts. So people who are in the robotics, see, one thing I experienced with the students, we have been running this program, undergraduate program in robotics since 2011. Uh, Almost all students who have passed out, or all the students who have joined this program, they are all highly successful. They have been to some of the top universities in the world. 3 students recently joined the ETH Zurich. One thing I observed from this bunch of students joining our program is that they are uh, they are actually different from the students who joined the other programs. So these students have high level of creativity, high level of imagination, and very active. So they need always work. We have to keep on feeding them with a lot of new stuff to create, and that is how they go out. And once they go out successfully, they create a lot of new things. So that is how these 26 entrepreneurs also have come up. So the teachers, not like the students, we should be one step ahead of the students to make them think, or make them think out of the box. Let us not confine ourselves to a conventional teacher. Think beyond that. Then only I think as a teacher in robotics, you should be able to explore more, do research, as well as to guide students. Okay, with this small history of 2 people who created the basis of this, the basic difference between Karl Kapek and Isaac Asimov, Karl Kapek was his time limited only to dramas, whereas Isaac Asimov started writing a lot of things. Being a scientist material, he used to propose uh, lots of laws of robots. So the basic 3 laws of robots, law 1, law 2, and law 3, are all taken from his science fiction novel. Nothing from an engineering textbook. So this, if you have seen the movie I, Robot, Will Smith, I think he is saying these laws, like a robot may not injure a human being, or through inaction allow human being to come to harm. So fundamentally, robots should not harm humans. Robots must only obey the orders given by humans, and it should not conflict with the first law. So no human should give a command to harm any other human. And a robot must protect its own existence as long as protection does not conflict with the first law. So robot should protect itself, and in the process of protecting itself, it should not harm any humans. So I think there is some noise. Please mute. Okay, thank you. So the whole essence is that robots should be only followers. We should not harm any human. But recently, if you have observed some of the recent conflicts that are happening between countries, robots are also used to harm people. Robots are used to kill people or are being now used. Like drone, which is also a form of robot, is used to target people, target places, buildings, and destroy them. So though it is against the laws of robots or robotics initially designed, yes, unfortunately such things happen, and probably they have justifications of themselves. But anyway, these are the three laws of robots which were taken from Isaac Asimov. So basically, why robots? It could have been only in movies and dramas. Why, or in novels? Why people have adopted robots? Because the only objective is to make our life more comfortable. So there are now robots to clean rooms, robots to monitor patients, robots to take care of infants. So a lot of robots have come to our household. As in iRobots, I think by 2050, every house will have minimum one robot or more than one robot. So most of you in your, if attending this in their 30s, probably when they retire and in their last age, in their 80s or in their 70s, you will be taken care by some robots, who knows. So that is how the technology is moving. So robots are used extensively where consistency and quality of work is demanded. So that is where industrial robots have become very popular. Whether it is machine tinting, whether it is welding, whether it is pick and place, whether it is painting, whether it is assembly, whatever be the task that we assign to an industrial application, robots are much more consistent, much more accurate, and they don't feel tired. They work 24/7, and they have now almost replaced the industrial jobs. China is the one country where in 2020 there were 140,000 robots introduced into the industry, and that is only for 1 year. So it keeps on adding. So it probably lakhs and lakhs of industrial robots are in Chinese factories. Though China is the country with highest population, we have been taught in our classes or maybe in schools that robots are not suitable for a country like India because we have a lot of manpower. But China is the country with highest manpower. They are the country with highest number of robots. So is there any connection between these two statements? No. It doesn't mean that if you have a lot of people, all the people are going to work and going to work consistently and give you quality products. That is a misconception. People are there, but you can see whenever there is an opportunity page or whenever you look forward some job openings, every industry has job openings. People are finding it hard to get workers to work in their factories. Coimbatore is predominantly or famous for industries like foundries, pumps and motors, textile, machine tools. Such industry earlier used to have a lot of people working, but over the last 20-25 years, because I've been living in the city for the last 28 years, I've been working very close with the industry. I'm also an invited member in most of these industry forums representing PSG. One of their major complaints from industries, they don't find people. Earlier it was right skilled people. Now they are saying don't have to be skilled, at least some people to work. So much of human scarcity or workforce scarcity in industry. So foundries used to have a lot of people working on cleaning castings. So we call it as deburring. You don't get anybody now these days for deburring work. So such task which involves a lot of dust, noise, a lot of like unhygienic environment, you won't get even if you pay 1,000 rupees per day. That is the situation. Similarly, welding. Welding is a very strenuous job. You won't get, you know how much a very skilled, experienced welder takes per day as his salary. The participants from other cities, if you have any idea, or other states, if you have some idea about that, can you just share? In Coimbatore, an experienced welder will minimum get 1,500 or 2,000 rupees. 2,000 is minimum, 2,000 rupees per day. Otherwise, you won't get a welder. Any idea about other places? Punjab, Ludhiana, Ahmedabad. Okay, it varies. You can just find out. So, though we have a lot of manpower, we also said that we have unemployment. People are not ready to work on several fields that require hard work, where you have to produce consistent quality as well as dependability. So it has been proven that in all these areas, robots are the best alternative, and it is increasing steadily. Coimbatore foundries have gone towards deburring robots, robots for welding, robots for pick and place, robots for packing. So there are a lot of robotization happening throughout India, but the pace at which that is happening is much slower than what is happening in China or other developing countries. So robots are used where repetitive jobs are strained, and there are dangerous environments, especially like handling nuclear materials. All the nuclear reactors materials are handled by robots. That is why materials that are harmful for humans, whether it is a short term or long term, with radiation effects, all these areas we can't employ humans to work. Some of the typical applications in the industry of the industrial robots: welding, gluing, spraying, trimming and deburring, testing and gauging, assembly, material handling, sorting and packing, and a lot of machining. Earlier days, CNC machines were used to do machining, but now there are a lot of flexible applications where robots can do machining of components, because the accuracy levels of robot positioning has drastically increased. So when we talk about robots, there are two categories. Fundamentally, there are two categories. One that caters to the industry. So this started from 1950s. You know, who made the first industrial robot? Which company? The Uni made its first Puma robot, which was used to handle picture tubes in television manufacturing industries. That slowly changed the industrial robot sector. Now in each and every industry, you can see robots. We will see in detail about its different configurations. So industrial robots forms one group, and the second is service robots. So service robots includes everything put together, like underwater, unmanned aerial, then on the surface of water, land, then robots for surgery, robots for taking care of people, patients, elders, infants, teaching robots, and whatnot. All those things we put it in another basket. We call it as service robots. We will see how big is this industry. Whether is there any point in doing an FDP in industrial robots or service robots or robots itself? Is there any future? If there is no future in this industry, there is no point in studying a program that will not be of much use. So the industrial robot market, this is from market analysis, a press release from Investor Relation and Presentation Annual Report. The market size has been steadily increasing, and in 2019 or 2000, the expected by 2020, last year it was around 50 billion US dollar. That was then the market of industrial robots. 50 billion US dollars was the sales that happened throughout the world. In 2024, the projected is around 75.6 billion. So we can see the rise in next 4 years. So certainly the industry is growing. New technologies are coming. When the technology is growing, industry is growing. That means a lot of opportunities for placement, jobs, training, research, all these things. So that promises that this is a growing field where you can confidently step in and start exploring this field. And if you see the size of the industrial robots worldwide, 15 largest markets. So with this again with respect to the World Robotics Association Survey 2020. So China tops into 2019, 140,500 industrial robots were sold or installed. Of this, 30% of the robots were made in China, the remaining 70 from other countries like other famous brands. But China now has got their own robot brands, which are also available in India these days. But because of our recent policy changes, we have reduced the exports from China. Japan has got the second place with 49,900 robots installed in 2019, followed by United States, Republic of Korea or South Korea, Germany, Italy, France, Chinese Taipei, Mexico, and India in this spot with only 4,300 robots sold or installed in 2019. So considering the size of Indian industry or the size of India, this is not that big number, but this has been steadily increasing. India has reached a spot. 2 years back, we were not even in the picture. We were not in the top 10, but we have come to a stage. Now we can see first is China, second is Japan, third is US, fourth is Korea, fifth Germany, sixth Italy, seventh France, eighth Taipei, ninth Mexico, and in 10th position we have reached. So we came from almost 16 in the 2018 and jumped to 10th position in 2019. And this also surely will go up. We will be crossing Italy soon. So that many industrial robotization is happening in the industry. Any new manufacturing facility you take, there are a lot of robots. We recently saw the India's cheapest car. What was that? Tata Nano. Even that car factory had 139 industrial robots. So any kind of manufacturing activity on a medium or large scale that is going to witness in India, there is going to be a lot of industrial robot applications. So that is about the role of robots in industry. So this has been steadily increasing, and that promises that we do have a lot of opportunities for robotics in India. So we need more and more engineers, qualified engineers who can program, handle, design, maintain, service, and commission these robots. And we do require a lot of researchers who can come out with new solutions for the industry in terms of robotics. That is one sector. And coming to the service robots market, that is another unexpectedly growing market. You can see the change that is happening in the service robots. It is marked in gray. So 2016, when compared to industrial robotics, the market was too small. It grew by 124% in 2017. It grew by 61% in 2018, 33% in 2019, and 2020 it saw around 30%, and 2025 the value is going to be 102.5 billion US dollar. So it has almost crossed industrial robot. Industrial robots predicted is only 75 billion US dollars, whereas service robotics industry is going to cross the industrial robots market, and it's going to have a huge role in our society. So these numbers taken from the World Robotics Survey reports are to show you that yes, there is a lot of things waiting to explore opportunities and possibilities in this field, whether it is industrial or service robots. So be confident. If you want to start a program in BE robotics or ME robotics in your institution, yes, you can confidently go forward. Or if you want to do your PhD in robotics, or if you want to switch over to industrial job in robotics, yes, you won't be disappointed. It is going to be highly demanding and remunerative. Okay, now we will see what is robotics. I know, see, it's too fundamental, too simple for you to understand these things. Most of you will be knowing, but still, since we are starting from scratch, I thought, okay, I'll just brush through these things. I will not take much time here. So robots can mimic certain parts of the human body. If you see the industrial robot manipulator, it is basically a human arm. Now there are industrial manipulators with 2 arms. So industrial robots with 2 arms. Earlier, there are also with 1 manipulator, 1 arm. And these are available in various shapes and sizes. Size and shape critical to the robot's efficient operation. Many contains elbow shoulders, which represent, we call it as degrees of freedom. So the technical term that we represent an axis in a robot, which is similar to an axis of a CNC machine, is the degrees of freedom. So that means how many degrees a robot has, the number of flexibility. How many degrees of freedom your forefinger has? An exercise. All of you now just find out and let me know how many degrees of freedom your forefinger has. One choice option A 1, B 2, C 3. So there are 3 degrees of freedom. Could you able to find out what are those three degrees? Okay, you explore it. Motors provide the muscles. Control circuit provides the brain. And if with your brain commands, if your brain is active, if you have been listening to what I have been saying, so your brain received the command and you would have tried moving your 3 degrees of freedom in your forefinger. And there is 1 degree of freedom which has got more flexibility than the other 2. So then we should understand the different types of the joints. We will see that. So basically, when you look at your forefinger, you can see that your forefinger consists of links and joints. So in which way these are connected, that defines your type of the degree of freedom. We'll come to that later. We'll see where these robots are used. So 50% of these robots are in Asia, 32 are in Europe, 16% in North America. Factory robots is used as mechanical production. Okay, this we already seen. And other robots like bomb disabling, exploration of volcanoes underwater, other planets. The Valkyrie robot, which I showed you in the first picture, it is for exploring the Mars surface. Cleaning robots, lawn moving robots, pipeline robots, fruit harvesting robots. So there are a lot of other robots. And when we talk about robots or any machine which is practically there, we should also understand their industry, like who are the major players. So I have listed here some of the brands that are available in India. On the left side are all imported robots: Yaskawa, Kuka, Hyundai, ABB, Kawasaki, Universal, Fanuc, Panasonic, Nachi, Omron, Adapt. They are all made in other countries. And this list mostly are Indian robots: Carry robots, MCI, Systematics, High-Tech Robotics Systems, TAL, Shastra, Defacto, Precol, Epica, PSG. They may not be so popular. They may not have much presence when you compare to the multinational players. But apart from the list which I have shown on the right side, there are several new companies coming up. Hope some of these companies will become so big, like they can also compete with the global giants. But the positive sign is there are a lot of Indian manufacturers coming into the industrial robot manufacturing sector. When you talk about the industrial robot structure, basically there are of two types: the physical configuration. One is the serial kinematic structure. Second is the parallel kinematic structure. The examples are seen on the screen. So it's a serial, like our forefinger or our arm, human arm. So power basically transmits from this to the end. So with the joint operation of all these joints, you'll be able to position the end effector. So it's serial points. In the case of parallel kinematic, you can see the parallel arms. So parallelly we move to make this end effector position possible. These are the two possible mechanical configurations. Inside this serial itself, there are different types. You will see one by one. We will see some of the most popular type. Can anyone say which one is A? What is A? What is B? What is C? What is D and E? E we just saw. We call it as parallel robot or parallel kinematic or delta robot. All are same. This configuration E. And the D is a gantry type. C is a SCARA. B is a cylindrical robot, and A is articulated. So based on the construction, it has been different. There are actually 7 industrial configurations. There is one called Polar, and another called Cartesian. So those things are not shown here because here it is only the most popular ones or which are currently employed. Spherical robots are now almost obsolete. Sorry. So that is articulated, and cylindrical, SCARA, gantry, and delta. So these are the possible configurations of robots you can see in the industry. Of this, the most popular is the articulated. Where will you use this? So articulated, the usage depends upon 2-3 parameters of these robots. The major specifications what enables the user to choose which one is the best for our application. One is its work volume. What is the reach of these robots? So which one can reach our application? And sometimes it is the speed, sometimes it's the payload, sometimes it's the travel length. So considering all these as our selection parameters, we do go for which one to pick. Any questions so far? Okay. And when we look into the robot anatomy, what are the major parts of any robot? This is explained with reference to the articulated robot. So there is a base. Normally you can see the screws. So this will be clamped to the maybe a ground or maybe a table or wherever you want to mount it. It will be mounted. So there is a link 0 and the joint 1. So here this can move like this. Then there is joint 2. So there is the link 1. Between joint link 1 and link 0, there is joint 1. Between link 2 and link 1, there is joint 2. So this moves like this. And between link 2 and link 3, there is joint 3. Or like this way. And there is an end of arm. Here there will be an end of arm. So you can mount your end effector. It may be a gripper or it may be a welding torch or whatever be that. So the end effector or the end of arm has the tool, maybe a drilling tool. And this also maybe you could move. And the tool also can function. So 1, 2, 3, 4. So this is 4 degrees of freedom. If you can have 5 degrees of freedom or 6 degrees or so it depends upon the number of joints. So basically these are made by links and joints. So this number of links and joints defines the degrees of freedom of a robot. And these joints are of different types. One, it can be a translational motion. So a linear joint. So there is an input link and there is an output link. So this one link moves inside this joint. This is joint. And inside this, it moves. So the joint motion is like forward or reverse. This is something similar to the telescopic antennas, right? So one link moves inside the other. We represent this by the letter L, linear, where there is one input link, one output link, and the output link moves inside the joint is represented by the letter L, linear joint. In the same configuration, if you have a configuration like this, input link, and on top of that, the joint where the output link moves. So it moves over the input link for the entire length. This type of joint is called as orthogonal joint and represented by O. So if you please understand from the basis, industrial robots are made of only links and joints, and the different type of joints are currently we are discussing. When we say a joint of type L, means that it's a linear joint. If it is an O joint, it is orthogonal, means it moves orthogonally on an input link. So these two forms under the translational motion. Second is rotary motion, in that we have rotational joint. So this corresponds to rotational joint. Second is the twisting joint. So there is a joint on that output link moves like this. It's a twisting. Whereas here it goes forward and reverse. And the revolving joint, input link on that, the output link can revolve. It is not just twist. The output link will revolve around its input link. So that is the third type, represented by V. So R represents rotational, T represents twisting, and V represents revolving joint. So any industrial robot that you can see in an industry will consist of a combination of any of this or any one of this. It can be LLL or LOT or LOR. So it's a combination of any of this type of manipulator joints. And we discussed like the selection of these robots or the performance are decided by some of the factors like size of the working envelope, how far this robot can reach, and how precise are their movements. So one is decided by the control resolution, the control system resolution, as well as the entire mechanical system's ability to trace that control system command. And that tells us about the accuracy of the robot and also on the repeatability. So what is the basic difference between accuracy and repeatability? If you are able to position at 1 micron for the next 100 times, if 100 cycles, then we can say the repeatability is very high and there's a good accuracy. Suppose it says for first time 1 micron, second time 8 microns, third time 15 microns, fourth time again 1 micron, then there is no repeatability. Though accuracy is within its range, there is a wide variation in its repeatability. So robots are supposed to provide high levels of repeatability and also a good amount of accuracy. But when it comes to accuracy, it is not as accurate as when we talk about CNC machines, because in a CNC machine, it moves over a guided system on a linear guided track, guideways. So positioning is much more simpler than on a free space, like in the case of a robot. And the lifting capacity defines the payload. So payload means the load of the end effector plus how much of weight the robot can lift. So if some robot manufacturer says that the payload is 6 kg, that doesn't mean that it can lift 6 kg of weight or carry 6 kg of a tool, but instead, if you are having a 2 kilogram gripper, then you can have 4 kilograms of weight the gripper can lift. So it is the weight of the end effector plus the possible weight the gripper can lift. So that is the payload or the lifting capacity. Then the number of robots axis, that means the number of degrees of freedom. That is another parameter for selection of robot. Then the speed, maximum speed, acceleration. This is important in the case of loading and unloading, because if the robot movement is not fast enough, the feeding machine, the machine which we feed through the robot, will have to wait for a longer time, and that increases the cycle time, which in turn reduces the productivity. So the speed of the robot action or the movement, the acceleration as well as the deceleration time of each degree of freedom, these are again critical parameters for the performance specifications of industrial robot. Then motion control path control can be path controlled or velocity controlled. Anyway, this can be configured. And types of drives for the actuators, it can be hydraulically driven, electrically driven, or pneumatic. Pneumatic will be the cheapest one, but these are not meant for high position or precision applications, but they are very fast. Hydraulic driven can lift more weight. It is smooth, but a lot of issues with accuracy as well as positioning as well as maintenance may have to be addressed when we go for a hydraulic actuated robot. So the best bet is electrical actuated robots, and servo motors are the most preferred one, though we also use stepper motor driven industrial robots for low weight applications as well as for trainer robots. Okay, this we just discussed. And on the overall robot functional diagram, So one is the computer control system. Every robot needs a computer control system. And there are a lot of sensors used in robots. Some are internal sensors, some are external sensors. Internal sensors like encoders, resolvers, pulse coders, proximity switches, Hall effect sensors, those are kept inside. And some external sensors like machine vision systems, they are kept outside, which will be integrated to the robotic system. And the end effector systems, it may be a weapon system, if it is for a defense application, or the industrial kind of application system when it is for an industrial in-house application. Another important functional area is the human interface system. So the humans have to interact with robots. We have to teach these robots. We have to do a lot of maintenance. We have to take a lot of document support. So testing, training. So every robot, industrial robot is probably, not only industrial robot, any robot system has got a human interface. Maybe a touch panel, it may be an LED panel, or some way of system where humans can input commands. It can also see what's happening inside the robots. It can see the status, the machine healthiness. All these things can be understood by the human interface system. So this is an overall picture about the robot functional system. And the robots from factory, we discussed about the industrial structures or the industrial configurations of robots. From the industry shop floor, robots have moved or expanded to entertainment, toys, personal services, medical field, surgery, mining, harvesting, space, underwater, and a lot of applications. It's on increasing. And that we put together as the service robots industry. So some of the major service robots that are available today. One is the humanoid, human-like robots. So this has been fascinating humans for a long time. We tried to develop a humanoid in our department right from 2011. It was funded by a company, and we completed the design, evaluated by a multinational company, and it was handed over for that company for production. When we were doing that research, we found out that 262 companies around the world and universities around the world, they are doing research in developing more and more intelligent humanoids. So our last session of the FDP, I'll be talking on the research possibilities in industrial or in robotics. So I'll touch upon that, but since it has come here, I'm also referring here. Every field, whether it is a humanoid, yes, it was some years back, 262. I'm sure 300 plus organizations are involved in developing various kinds of humanoid robots or even animal-like robots. You would have seen some of the videos of humans as well as animals. Boston Dynamics, another company that makes the pig dog. So there are a lot of products that have touched the attention of people worldwide. So basically, you can see humanoids can handle people. They can save people from war fields. They can take people from one place to another. There are humanoids that can teach students. When we made a visit to Korea, I found some of the schools, since they have a shortage of English teachers, some of the schools in their elementary classes, they are using robots as teachers, because in the preliminary stages of English teaching, the teachers, they do rhymes, stories. So here they found by using humanoids, it is much more effective than using humans. So there are some areas where humanoids can do better than humans. So this is another expanding area, and humanoids to take care of aged people, like humanoids. Aged people, they would like to talk a lot. They will be going through their experience in life, and they want somebody to listen to all their heroic acts as well as their problems. But today's problem is that we don't have enough time to listen to all these things. So a solution which has come in other parts of the world is humanoids that can listen, not just passive listeners. They can be actually active listeners. They can ask questions. They can give some response. They can even hug the old people and sometimes console them. So that level of humanoids have come to the market. In the bottom picture, you can see a surgeon doing a surgery with a robot. It's not that robots are doing the surgery. It's robot assisted surgery. So surgeons are assisted by robots for completing a surgery. What is the benefit of this? So if you see that picture, there are only 3 people inside that room. But if we compare that with the surgery picture of what is happening in our hospitals, where there are no robots, there will be around 10 to 12 people inside a room, crowded, nurses, attendants, and people for like several people, technicians around the doctor. There are 2, 3 doctors, a lot of chaos, right? So this may lead to mistakes. And here, since it is a robotic surgery, there are non-invasive, most of them are non-invasive. There are cameras that goes inside the patient, so the surgeon can zoom it and see what is the operation being performed, whether it is cutting onto the unwanted area, and less sedations because it is non-invasive, and the patient can come back to life much more faster than in a conventional surgery. At the same time, the surgery time has been considerably reduced. The risk of infection, because less number of people on the theater. So several advantages, and since this surgeon can do more surgeries. If in a conventional surgery, if a laparoscopic surgery, if there are 5 surgeries can be done on a day manually. If you are using a robotic or robot assisted surgery, they could do around 10 surgeries. So it is almost double. So the productivity is increased, more patients will be benefited, less fatigue for the doctors as well as the patient. Coming back to life is much more easier, no big cut marks. So several advantages for surgical robots. This industry is picking very fast in India. So far, I think around 75 surgical robots are available in India. In my city, we have 3 hospitals with surgical robots. So every city is now having more and more robots for surgery. Then underwater robots, very difficult for humans to go and survive. We have seen several movies these days, rescue people from ship or submarines, as well as getting things out of the old sunk ships. So very difficult terrain where people cannot go and survive and cut off life. So underwater robots have become a big market. Actually, I don't know how many of you are aware about this. This market has grown big because you know that the business that happens on the sea is much more bigger than what is happening on the land. Why? Because 2/3 of the world is water. right? It's more of water than land, and a lot of things, legal and illegal, happening inside the sea. So on the surface of the sea as well as under the water, a lot of things happen, and a lot of high technology is being employed, and robotics is one such technology that is being in underwater applications. Similar in the space as well as aerial applications, unmanned vehicles, unmanned flying vehicles, unmanned aerial vehicles, drones. So this is another big area where a lot of service robots are employed. So we have read news that some countries, they have started air taxis using drones. So drones can go pick people and drop people. There are drone ambulances. There are drones to pick people from war zones. So once I had an opportunity to witness a 100 kg payload drone made by a university in US, used to go to the nearby islands and collect biological growth of plants as well as other marine biological things for scientific purposes, for studies, to predict how the environment behaves, the climate change. All these things are studied by collecting samples from islands which are like there is no humans there. So in the medical robotics itself, there are various applications. Surgical robots used for laparoscopy, orthopedic, neurosurgical, steerable robotic catheters that can be injected to a patient, that removes the block, and the robot is made with such a material that this robot can dissolve inside the blood itself. You don't have to take this small micro robot outside. So this robot can be injected, it can be navigated from outside, goes inside your block or inside the heart where there is a block. It drills, removes the block, and the robot dissolves inside the blood, and the block is removed. So from micro or nano robots to completely manned surgical robots who can take care of patients. So surgical robots is a big field, and one company we can Google and see some of the videos is DaVinci. DaVinci is like a monopoly in surgical robots. There are other companies. We also did a project on a endo trainer. So that means when you have so many robots for surgery, the doctors who are going to do this robotic surgery needs to be trained. So there is a requirement for robots to be trained. But if you look at the cost of the service, surgical robots, especially let us say laparoscopic surgical robot of DaVinci will cost you somewhere around 15 crore. So you know the economics of that, the machine hour rate of that. It's such an expensive machine. So hospitals may not like to keep these robots idle. So there will be a repetition of, or there will be a number of surgeries happening every day. So if you want to train young doctors in that, you may not find the space for that. It will be too expensive to waste that kind of a robot for surgery. So there are such surgical robots for training purpose. We call it as endo trainers. May not be of that high accuracy, but almost the same features with a lesser accuracy levels and less cost are available for surgeons to get trained. So in our department, we have also developed such a robot. I showed you in the first about the profile about the department, a robot built by an endo trainer built by PSG as well as with L&T Technologies and cased. So this is another market for medical robots. Then rehabilitation robots, therapeutic, assistive, and exoskeleton. Exoskeleton is again coming up. Exoskeleton is also coming up in a big way because a lot of people with problems in their back, in the vertebra, in lifting weights, in walking. So this can be solved using an external support system. It is again like a robotic system that can support humans. Then we have, during this pandemic period, there is a new thing that developed: diagnostic chatbots, disinfection bots, robots, robot nurses, pharmacy to handle medicine. These all things got a recent boost during the COVID, because it is better to avoid humans, and humans also would wanted to avoid less human, other humans, as this virus can easily spread. So a lot of robotic nurses. Okay, this is another picture of the surgical robot. So the patient somewhere here. So there are two types of medical surgical robots. One with a real industrial lamp configuration. This is on the right side, and the other with the completely medical robotic configuration. So there are different slave stations, and this is the master console. So the surgeon sits on the master console and operates with his fingers, and all these slave arms moves accordingly and does the surgery. So with this on the screen, the surgeon can view and he can see what is happening inside. The same view is also provided with the other supporting stuff here. They could also see what is happening or what is being done by the surgeon. Another advantage is that everything is recorded. So even if something goes wrong, you can see these things later. If you need any legal files, like everything is recorded, stored, and it also gives us some alarm. Suppose somebody does something and forget to take something out of the patient. So all these things are easily traceable. Unwanted area will not be touched. These are some of the benefits of surgical ones. So the medical endo trainer developed by our team. So you can see the surgeon in Coimbatore trying to get his hands on the one which we developed with L&T Technologies. So this has come to a shape, but again, some more fine tuning is happening. Hope this robot from Coimbatore will make history. And some of the other robots, this again, I told you about some of the entrepreneurs from the department. So this particular robot was made by a student from our department, and it's been tested in PSG hospitals. So this is a picture which was taken from PSG hospitals. And during the COVID time, this robot used to deliver some materials to the ward. And these are physiotherapy robot. Then we have, doctors can guide in rehabilitation work, and disposable, like material disposable, like linen, bed sheets. This can be handed over to the nurses as well as medicines. And UV disinfection robots is again another product from our own students. They have made a UV disinfection robot. There are other products. I'm not just saying only our students, but there are several such robots that can follow a programmed path and do the disinfection and stand somewhere outside once that is done. And after every 8 hours or 12 hours, this can automatically go and do the same task. These are pharmacy robots where, according to the prescription, these robots can go pick the medicine from the rack and deliver to the patient, or maybe the bystander who is there to collect the medicine after payment. Yes, another one during the COVID time, the swab collection for testing. So you can see an industrial robot. This is a collaborative robot by Universal Robot, used to collect swab from a patient, and once it is collected, it will be shifted to the next machine for processing. Then ultrasound scanning robot. So instead of a radiologist who can, or maybe the doctor who can take this manually, the props, and do the scanning, if the patient is lying nearby and if it is programmed, a robotic arm can do the entire scanning, and the result can be sent to the doctor. So doctor need not come closer to the patient and do the scanning. So scanning can be done by the robot. This is another revolution that is happening in the medical field about the diagnostic chatbots. especially this evolved during the time of, again, the COVID. So when we are having some illness or when we feel we are not fit, we have to consult a doctor. But now what we do is immediately you can Google it and see, based on our symptoms, what are the possible causes and remedies and what kind of medicines you have to take. But in this medical diagnostics chatbots, instead of just literature that is available from the internet, it asks you for, it already has some of your data and your age, your kind of, even it can also trace back to your genetic history, like you originated from what race, what have the common diseases you have been having. So at this rate, at the age of 60, what are the possible ailments you may face and what kind of lifestyle you have to take care of in order to avoid that or in fact reduce the level of that infection. So it's a kind of a predictive maintenance. So a predictive kind of treatment could be taken when you have the help of the diagnostic chatbots. And as soon as you feel something not well, you can talk to these bots and it tracks several new data. Even you can feed new reports, it goes to the report and like a doctor. So it's basically an AI-based system. So the doctor's intelligence is built into the system. So the system does the diagnostics test and comes out with a suggestion that probably you are having this disease. And to take it further, if it is a serious issue, the chatbots will even connect to you to the experts or doctors in this field who can do the next phase of your treatment. There are various autonomous robots. So some of the pictures you can see, one may be a mine detection and demining application. So it can be navigated. So wherever people, it is difficult for people to move, it is dangerous for people to go and step. So this can be initially triggered. This goes and find out those things and can weaken that and come back and make that path safe for the humans to move. Similarly for patient care systems, so you don't have to have a nurse always standing next to a patient. Sometimes we need continuous monitoring of patients. So instead of saving humans time, there are robots that can continuously monitor and sometimes not support, or whenever there is an emergency condition, the robot can inform the senior doctors about the attention is required. And the autonomous cars are coming, autonomous flying machines, autonomous surface boats, autonomous underwater systems, autonomous systems for space. So a lot of autonomous systems are going to come, are already there, but in our life we are going to see more and more. These are all avenues for us to explore further. When you want to do something, some research on areas like autonomous system, some of the terms like perception, localization, cognition, and motion control. So you need to be confident in writing algorithms on localization. So if you take a robot from one room and keep it in another room, the robot should be able to understand where I am currently sitting or standing and how to move from here. So it is fitted with sensors like cameras and lidars. So with the help of these sensors, it will be able to map its route. But the first thing is it has to identify where its starting position. So if you should need to add this intelligence to this kind of systems. So some of the autonomous vehicles we have developed here. So the last one is an all-terrain vehicle which can climb stairs. And these are small mobile platforms. Yes, you can teach how it has to move. So the mission planning has to be done, path planning, sensor interpretation, obstacle avoidance sensors may be there, and terrain sensing. Then failure handlings or recovery from failure, these mods to be set inside these machines, because these may be deployed in unmanned areas. So once something happens, how to recover from those failures. So basically, this kind of mobile platforms are of four types. One may be completely controlled by humans, like with a joystick. Another is a supervised one. Another is automated, and the last is autonomous. Control means a system that requires activation, direction, and manipulation by a person. Like you have a drone, the drone is controlled by a joystick. Yeah, that is a controlled kind of a navigation system. But now later we have a programmed path or supervised, maybe from one location. We can see whether the drone is taking off and is it going fine. So it's supervised, but its movement is already programmed. Automated means, yeah, it is programmed in such a way that, yes, every morning at 6 o'clock, it has to go for a round, check all the boundaries of the premises or maybe the country, and check whether any intrusion. So collects, captures data, and comes back and feed it to the system what is being controlled, or it's controlled by the system. Autonomous means it takes decisions on its own. So if it sees that something is going to on its way, it can take decisions. Yeah, this we discussed. Supervised, an example of this. Automated. So here maybe a robot that can be taken to the war field, so it can detect from which side the gunshots are coming. To that side, this also can do firing. And the autonomous, again, with the difference to the defense, there are now bombs that can be navigated. You don't have to drop these bombs from a flight. Instead, this can be navigated. So suppose if you want to navigate your bomb to an enemy location inside the headquarters, and then you want to make it blast, yeah, it can be done these days with the help of path planning techniques and navigation. And it's on intelligent systems. It can even detect whether it has to blow it off or it can come back. And that's about an introduction to the present day robotic systems, the different types, industrial and service sectors. I would like to show you some of the robots developed by our department. So here sometimes students are also part, and sometimes we have faculty members, and there are some engineers who are responsible for development of this. So there is one 10 kilogram payload articulated robot. There is another 2 kg payload articulated robot, one with servo and another with stepper. And this is a COVID-19 temperature scanning kiosk and some Bluetooth enabled mobile platforms. And we also develop trainer robots with 3 degrees of freedom as well as 5 degrees of freedom. So it will be easy for teachers as well as to students to understand the motion dynamics and kinematics of robo manipulators. So if anybody is interested, we'll be able to, yeah, we can send you some these miniature robots so that it will enable you to understand the kinematics of these robots. We sell it at a very reasonable price. So these are some of the, we have also made a drone, and this drone recently got the South Zone first prize and national-wide third prize in the drone dancing competition held by the Ministry of Aviation. And this is an educational bot. You can make this bot to dance. You can make this bot to walk. So these are some of the products that we have developed. Why I am showing you is that if you want to develop expertise in robotics, you need to start building robots. Robots, I'm not saying the big industrial robots, but a scaled down version of everything is possible. We have now servo motors, not the industrial servo motors, but servo motors that can be controlled and with better accuracy and positioning. So with all these available things, you'll be able to configure it. You'll be able to, with 3D printing facility available these days, you can fabricate any part and connect your motors and sensors, you design and develop a product, a robotic product. If you make at least one, then I think you will be confident enough to proceed further in this direction in exploring more and more robotics. So several projects, several funded projects. I'll tell you about the research possibilities in our last session, but huge potential is there in this field. Let us learn this, equip ourselves, and then transfer this knowledge to our students. With them, we can also learn with our students. They will do a better job because, as you know, the present generation students are very good in developing coding as well as control systems. So you just define them what you want, they will bring you the solution. And with that, you will be able to design several solutions for the society. You look around, there are ample opportunities. There is a sewage cleaning robot is required. There is a fish cleaning robot is required. So every application possibilities of robots are there. That is why in one of the earlier slides we said robots are here to make humans' life comfortable. We don't have to spend our time and energy in things that are not much of value to us, or it will add value to others. Instead, machines can do that. This kind of fantastic robots can do that. So with that, it's time for us to wind up. So the remaining time, probably I will wait for some questions. So the basic objective of this session was to give you an insight on what is in store for us in robotics. In the remaining sessions, in the next few days, other professors will be teaching you on the various other components, like the power electronics part, the drives part, the motors part, sensors, the mechanical systems, the motion control systems, kinematics and dynamics, and sensory systems, and how to write programs. And they will also show you some demonstrations on how to make things move. So these are, so this session is only an introduction to that with some history and major elements, industries, major players, possibilities, configurations, and yeah, some of the applications. So now I think all of you can ask your questions, or you can post your questions.
Sir, Professor Jayakumar asked one question, sir. How robots will help in 3D printing?
Okay. We are actually making, we have a project right now from Department of Science and Technology on metal additive manufacturing. So we are trying to develop a metal additive manufacturing machine. Initially, we thought of going with a machine tool configuration with a 3-axis. But after going through 1 year of research, we found out that it will be better, or it will be an easier solution if it is a robotic 3D printing. So robots are recently being used for metal additive or even any kind of additive manufacturing. We can also do welding, additive welding, which we have done in our lab. Probably when Dr. Prabhakaran is taking a session for you, he will be able to show you the samples of additive welding what we have done. So additive manufacturing has a lot of scope that can be solved by robots. Okay, there were some questions. Okay.
Sir,
yeah.
Sir, I have received 2 more questions from Professor Karpal Kalra. The first question is, please explain work volume again.
Yeah, I am also reading those questions. So one is about the work volume. I would, because I can show you a slide, but the better thing is that you can also see from anywhere. The work volume is your end effector, the reach of your end effector, what fashion the end effector can cover your work area. So it depends. On a SCARA robot, it is in a different fashion. in an articulated robot, it is different. In the case of a cylindrical robot, the work volume is different. So basically, the work volume means how much this robot, how big or the area by which the robot end effector can cover. So if you are going for a welding application, it depends upon what kind of a table you have, it depends upon how much length, depth, width, all this you have to reach. So that defines the kind of the fixture you have to use for your welding. Like if you are going to have a bike frame to be welded, it is not the work volume alone, but even the job also could be moved inside the work volume, so that robot need not have to extend up to its maximum length. So there are various possibilities for exploring this, but basically work volume means how long or how far the robot end effector can reach in a particular fashion. How to calculate degrees of freedom of a robot? You mean calculate or find out the degrees of freedom? If you want to just find out the degrees of freedom, you can count. You can between two links there will be 1 degree of freedom. But how to calculate means you are going to design a robot. You want to when you want to design a robot, you want to decide on how many degrees of freedom this robot should have. Again, that depends upon several factors, whether it is going to be 2 degrees of freedom, 3 degrees of freedom, 5 degrees or 6 degrees, based on your application. Here again, the other parameters comes into picture. The work volume, the payload, the accuracy. As you know, very simply with your common sense, when you have more serial connections, then the rigidity, the stability, the reach, and the payload. These are all subjected to the kind of the structure you are going to frame. So when you want to design on how many degrees of freedom you want to fix for a robot, it depends upon your application. That is why when we saw that 5 different classes of industrial robots, whether it is articulated or SCARA, everything is meant for a purpose. Parallel robots or parallel kinematic robots are best suited for pick and place and packing, like a confectioner, let us assume there are biscuits coming on a conveyor. You want to pick 6 biscuits and put it in a box. So this parallel robot can easily do that because its speed is much more than a serial robot. And not only in biscuits, a lot of packing applications, in medicines, in terms of food items, packing applications is parallel robot. So we need to identify for what application. Accordingly, we can choose a robot. How do we analyze parallel robot with respect to kinematics and dynamics? Okay, that's a question I think that can be addressed when we go to the kinematics and dynamics part of that, because it needs some knowledge on the forward and inverse kinematics, how to write, how to solve your kinematic issues. Probably, I think there is a session for that, in that it will be covered, because that needs more time for explaining. It's a part of this for session. It will be covered. I have seen the schedule, so that is there. If not addressed, I will be there in the last session. I'll address you on that.
Thank you, sir. So, dear participants, I hope that you have enjoyed this session. So, thank you so much, Dr. Nas sir, for your excellent presentation. And we have learned more from that, right? Especially from in the medical robotics part, we have learned new things from you. And I hope that it will be more helpful to all the faculties who have attended this session. On behalf of Sri Ishwar College of Engineering and Department of EEE, so we express our sincere thanks and gratitude for accepting and handling this session. Thank you so much, Vinod sir.
Thank you. And I could see one more question in the chat box. Is it possible to achieve zero error by using AI in robotics? It depends again, zero error in what? Is it in machining? Is it in picking and placing? Because the level of accuracy levels of these various configurations of robots vary. So there are robots that can give you 5 micron accuracy, that can give you 50 micron accuracy. So if your application demands 0 micron accuracy, then it has to be very, very precise. Like one application is in welding also. If you want to have a very precise welding, then we need to have some kind of feedback system. So if you need a camera or some kind of sensors, they can track, we call it as seam tracking. So it is a part of the welding, seam tracking systems are there. So you give that feedback to the controller. Yes, AI-based systems are there that can stream the path, avoid all the errors and make it as perfect as possible. So AI has got a good role in maintaining the accuracy as well. Thank you. Again, coming back, so thank you so much for giving me this opportunity to Sri Ishwar College of Engineering and Dr. Rajan Babu. And all the participants, please attend all the sessions. I promise you that this will enrich your knowledge. And of course, our knowledge, yeah, we transfer to our students and researchers. So this will be of great help for the country as well. So thanks a lot. I really enjoyed the session. Wish you all the best and see you on the last day. Bye.
Thank you, sir. So dear participants, we have posted the feedback link in the chat box. So kindly submit your feedback. And our second session will be starting by 12 p.m. on the same Google Meet link. Thank you. So if you have any query, you can post it in our WhatsApp group. Thank you.